Hello guys, welcome to my online CATIA 3D modeling class for 6 weeks. Today we are going to draw about the gear. It's very important, I think, in mechanical components, especially when you have maybe car. When you open your gearbox, maybe there is a lot of gears and for transmission. And this week we are going to practice to draw two parts, especially for Spur Gear model first, and second one is Helical Gear model. Okay, and this one is if you find and you open the gearbox, maybe from your car. If you have car, there is a lot of gears for transmission, and the function of the gears is, of course, to transmit rotary motion as well as a power from one shaft to another. A gear can also use to amplify the power and can be found, of course, in transmission gearbox in car. Okay, now we are going to draw some pinion gear, something like this. Okay. Next, this one is standard gear. You can find from source from this link, maybe available in internet. I just took the model from the internet, and you should know the basic understanding the gear. First is module. This module is actually the we call it the gear tooth size. It's a small gear. We call it this module 1, bigger one, module 2, and more bigger, maybe module 4. Each module actually determine the spacing between the teeth, and the pitch is module multiply the pi. It is the circumference of the circle. This one is circumference of the pitch diameter of the gear. And if you project this teeth or tooth gear in the become planar line or planar plane, it's actually the teeth gear, okay, maybe it's better change the laser point. And this one is call it pitch, between the spacing between equal size between two teeth, and there is a two thickness. It is, of course, the half of the pitch. So pitch equal module multiply pi 3.14. So the two thickness is of course divided 2, just divided 2. So, and in the gear we call it in this from reference line, or we call it the pitch diameter, this one. And there is we call it addendum in here, and dedendum. And this one is tooth depth, and tooth tip, and tooth root. And the definition of addendum usually 1 multiply of module. If example in here module is 3, so just multiply 1 multiply 3. So this one addendum is equal 3 millimeter. This all size is in millimeter, remember. Okay, So dedendum, of course, 1.25 multiply modulus, so equal 3.750 millimeter. See, of course, if you know addendum and addendum, so you can determine the outside diameter and root diameter by this simple equation. This is a D, yes, the pitch diameter. Oh yeah, sorry, pitch diameter. We have to determine first pitch diameter by the number of teeth multiply module. Number of teeth Z. Yeah, for example, in here for pinion gear is small gear and the gear is the larger one, and in here. So pitch diameter is teeth multiply module. So you know the pitch diameter is equal 36. Okay, so you can determine outside diameter in here by pitch diameter plus 2 multiply module equal 42 millimeter, and root diameter pitch diameter minus 2.5. Of course, this one is multiply 2, so multiply 2 of the dedendum, so 28.5 millimeter. Okay, and this also very important, pressure angle. Pressure angle is the 20 degree. What is pressure angle? Pressure angle is this one. This will translate from this state to here, and this one is actually pressure angle 20, which determine um, the inclination of the teeth. Maybe if you large pressure angle, you will have more slope of your teeth. Okay, understand? Okay, next. Okay, next we are going to draw this pinion gear. So the size is actually this one, this size. Okay, remember the first is we interested to draw the root diameter first, and then from there we can draw the teeth of the gear. Okay, let's begin. So the first is draw the diameter of root at the center from the original. I mean the origin point, not original, origin point. Sorry. Okay, about 28.5 millimeter, and then do mirror. I'm sorry, do the pad with the mirror extend. I mean, and then with length is we want to draw the thickness of the gear about 10 millimeter. Okay. We already have this open, so just go to part design. Okay, select this YZ plane. YZ plane, select. Okay. Or go to sketch directly. Okay, in here you draw for root diameter, and of course you give it the constraint. Sorry, constraint 28.5 for root diameter. Just exit workbench. Okay, now doing path with mirror extend. Select the mirror extend. How much? 10 millimeter. You can preview, and this one is for root diameter for base of your gear. Okay, for the next, we are going to the draw. Okay, this one is path. Okay, so next is do the sketch for this XY plane to draw the first circle of your gear. This presentation I just print screen how the complete profile of the circle with the pressure angle 20 degree. And the first you are going to do is in the CATIA, go back to CATIA, and this is sketch. First you are going to draw the root diameter again with coincident with the root diameter which we have already drawn, and the next is to draw another circle for pitch and base diameter and also for top diameter. So for pitch diameter we change to construction line. This changes for construction line, okay, and you just give it the dimension for the pitch diameter about 36 millimeter. For the base, I am wrong. No, I think let's see the base diameter is 33.829. Oh, we don't make a dimension in here. Okay. Okay, don't give the dimension from base now. And the outside diameter is 42. Okay, so in this case, draw the axis line. Draw the axis line. Make it 20 degree. Okay. So in this case, we create the intersection point with this axis and this pitch diameter. So where is the intersection point? Oh, here, point. Intersection point. Select this intersection point. Okay. It is line and this pitch diameter. Is it correct? There is no point. Okay, now there is a point. Very interesting. Okay, from this point, draw horizontal line. Make a constraint horizontal. Okay, make sure this horizontal. And you draw this from point from here to here and create the dimension same with pressure angle 20 degree. And fundamentally, this base circle, sorry, this base circle, it should be tangent with this line. This base circle should be tangent with this line. Okay, let me constrain with this line, which is actually we draw the center of the circle from this base circle. I hope you understand. We draw the circle, center of circle from this baseline. If you measure from this diameter of base circle is actually this similar with the geometry of the in the table 33.829. If you look at go back to the dimension, this is similar because this pitch multiply pitch diameter multiply cos pressure angle, so similar with this dimension. Okay. This one over constraint, so just delete. Okay, now make a intersection point between this line and this line. So you have point here, and you can draw the circle, remove the construction line, draw the circle from here to this point. So this one is your gear profile teeth. This one. To draw another circle, you need the little bit calculation. I show you in the PPT. Okay, you draw this first circle, and this you draw another circle by calculation of the arc and also the angle of the not pen of arc. Draw the arc with angle 15 from here to here by calculation of thickness of the teeth. Okay, this one is a simple calculation to determine the angle of your arc. The first is calculate the two thickness, of course. This one is just a module multiply pi, half of this module of pi. You know, we already explained in previous slide. This one to thickness. Okay. This one and this one is similar with arc length, which is 4.71 millimeter. And then, as you know, the basic mathematical equation, arc length is radius, pitch radius. This one is pitch radius multiply theta. Theta is this one in radian. So very simple. So we got the radian of the theta. So just arc length divided the radius of pitch. Pitch radius is 36 divided 2, this one. So you got this radian. So convert to angle, so become 15. Okay. And after this get arc, you just make a tangent line to the base circle. So this one you got the center point for your new circle. Okay. I hope understand. Okay. So just go to back the CATIA. As we know, the angle is 15 based on calculation. Now go to the arc, this one. Go to construction. So select first this from center point. From this point to here, and draw another line, and then you give the dimension about 15. Okay, very simple, right? And then you draw the tangent line with this circle, the base circle. Okay, from here you can do a trim, maybe. Where is the trim? In here, trim, quick trim. Okay, select quick trim, and this one is your new point to make a new circle. So select new circle here, select circle. From this center, oh, construction remove. From here to here, your new from the teeth thickness arc. Okay. Okay, now you have a two circle in here. This one is actually your teeth geometry. So what is next from the PPT? Okay, you have 15 from arc, draw from here to here, and make a line here, and draw 15. I make a constraint 15 degree, and then make a line tangent to the base circle, and this one become your new center point for your new circle. Okay, everybody understand? Okay, I hope you understand. Very simple. So in here, just do quick trim and just leave the teeth profile of the gear, and then this one just do the quick trim and remove all the line, and then just do a pad for the spur gear. Okay, and the dimension mirror extend 10, or you can use the next up to next. Okay, until here we do quick trim. I think double click in here. I think just delete this all. Yeah, double. Okay, I will delete. And delete the outer diameter. Okay, and the rest of this the base circle. Okay, this one is your teeth profile. I think there is no open profile. Check again. Yep, this one is your gear teeth profile. Okay, until here everybody can draw this picture, this profile. I mean, if you rotate something like this and exit workbench. Okay, this one is your profile live in the middle of the cylinder. Okay, go to path, mirror extend, select this profile. Maybe you can up to next. Oh, sorry. Up to next cannot. Or maybe up to plane. Or up to surface. Oh, and up to next cannot mirror extend. So select dimension. I understand now. Mirror extend. Oh yeah, just dimension and mirror extend. Okay. Okay, fair. This beautiful teeth gear. You already made it. Okay. Now very simple. So and next is just go to edge fillet. 1 millimeter for this two edge. Select this two edge, rotate. Okay. The next job is do circular pattern. In this case, using 12 instance and 30-degree angular spacing, or you can simply just use a crown. In here, where is it? Oh, here. Circular pattern. You can use instant angular spacing or complete crown. 24 reference element. Maybe x-axis. I do correct. I think it's wrong. I think too much. Oh, sorry, it is 12. Only 12. Okay. Okay. Okay, this is your gear. Beautiful gear profile. Okay. Your job is complete to make a gear profile. And then select back surface. Just make a extrude or pad from the back surface with 20 diameter and 10 thickness. This one front, this one back. Select this back surface. Complete position sketch. Horizontal and vertical axis like this, okay. 20 millimeter diameter, 10 millimeter. Okay, so this one is your gear, pinion gear, and the last is make the keyhole profile with this dimension. Go to front view, select the surface, okay, and go to position sketch, maybe. Okay, and go to circle in here. Maybe this one, rectangular, and select the keyhole profile. In here, draw like this, and determine thickness and diameter in here. So you just change it this dimension, which is 8, and the radius. Where's the radius? Radius is 1, and this one is still can moving. Oh, sorry, this one is 6. This one to here, that is 8. Okay, this one is your keyhole, which is with for gear. Usually there is keyhole like this to assemble to in the shaft. Okay, in here just think, just do pocket, exit, do pocket, and I think up to last. Yep, and then okay. And the final, select this surface again. Make it 25 diameter. I think do pocket again with the thickness about 10 millimeter. Dimension 10 millimeter. Okay. Okay, this one is your final pinion gear. Okay, you can save it. This beautiful gear. Okay. Now this one homework. We can CATIA class. You can anything. It's a pinion gear. You can save it. Okay. This is your beautiful pinion gear. So just do the first is make a root diameter, okay, and then create the profile of the gear as I explained previously, and you can uh, see in previous in this video previous method. You can go back and look at back how to create the gear, gear profile, and then just fillet. Just to fillet. After that, this one fillet in here. After that, circular pattern. That's complete crown or instant angular spacing is up to you. Complete crown, 12 teeth. Okay. And then just do pad and pocket for keyhole in here. Okay. This one your pinion gear. So in this presentation, only create the pinion gear. This one, 12. Okay, this one final. Your final pinion gear. For next is we draw the helical gear. Okay, in case of helical gear, the profile has the gear tooth has the helix angle, which is present in this angle, something like this, in here. And why the helical angle made? Because the in helical gear is can rotate more smoother than spur gear. So usually in transmission, the spur gear is replaced with the helical gears because this has smooth gradual contact with the each teeth, so make a sound silence, so it's a smoother rotation. And to draw this, basically the helical gear has contact in the normal plane, which is the teeth contact in the normal plane. So the profile of the gear tooth usually measure in the profile. So we have to translate this profile to the transverse plane. Okay. So in here we have the pitch for in here pitch relation is the pitch normal equal pitch for transverse plane. So we have to determine the pitch of the transverse plane. Okay, equal this one pitch normal, which is this one, divided cos of helix angle, this one. Okay, and then we have to determine also, and sorry, this one has relation between the pressure angle, which is a relationship of pressure angle normal and pressure angle on the transverse plane, multiply cos the helix angle. So this one relationship between two normal, two pressures angle between normal, this one, pressure angle normal, and pressure angle on the transverse plane. And the third one is the relationship between module size between normal, this one, and transverse. So relationship is module normal divided cos of helix angle. Okay, I hope you understand this. And then this one, helical gear geometry, I made it for you. This one is similar from this home page. We calculate first the okay, we know the normal module 3 and pressure angle of normal 20 and helix angle 30 degree and number of teeth 24. So we have to calculate how much the transfer module for the transverse plane. Basically, we want to draw this on the transverse plane on this direction. If you see this direction and this normal plane, actually cross section of this axis from here, you can see the cross section from normal plane, but we don't draw this one, we just draw this for transverse plane flow. So you have to calculate the transverse module first and then transfer pressure angle based on this relationship. Okay, we know 22.7. Okay, this one something like this, and then pitch diameter about 83.138. Okay, and I think this one pitch diameter is this one multiply this one, I think. Okay, and this one base diameter, pitch diameter multiply cos pressure angle of transverse. So you got this dimension, and then offset diameter This we have known the calculation, the pitch diameter plus 2 module, and then root diameter, pitch diameter minus 2.5 module. And we also know the addendum and dedendum is about 3 and 3.75 millimeter. Okay, based on this geometry, we want to make the helical gear properly. So next, of course, we just create the root diameter with this diameter 75.638 millimeter, and then do pad with the thickness 40 millimeter. We want to create the helical gear with thickness 40 millimeter. Okay, let's do it. Okay, this one is just close. This one, save and no. Go to part design. Okay, select this. The first thing you do is make a root diameter. How much? 75.638. And we just do pad and maybe reverse direction. Okay, this one reverse direction. Put in 40 millimeter. Okay. And we draw the base circle and pitch circle on this plan. Okay. First draw the root diameter, which is the constraint same in here. Coincident. Okay. And it has a dimension of top diameter, upper diameter about 89.138. Okay. And then pitch diameter, make it a construction line. The pitch diameter is about 83.138. And then for base diameter 76.644 millimeter. Okay. Okay, we just finished this step. Make it draw the outer diameter, pitch diameter 83.138. Okay, and base diameter 76.644. Okay, after that you draw the line, axis line with the pressure angle 22.796 degree, and then create intersection point from here and to here. Okay. Just make an axis in here. I think easy. Okay. Where is it? Okay. You know the degree? The angle is 22. 0.796. I'm correct. Am I correct? Yeah, correct. Okay. Similarly, from previous in the Spur Gear, I told you make a section point here. I think is okay. Okay, this one is your new point for circle. Okay, that one beautiful. If you draw the line in here horizontal, I just want to show you. Okay, make it horizontal. To here to in here. If this line is tangent, so this circle, base circle, this angle actually same with the lesser angle, which is 22.796. Okay, this is not necessary to draw. I think this one, this line, I think not necessary to draw, but I just give the example for you. I think you just delete. The important thing is this intersection line between base diameter, if you know base diameter, and the pressure angle. So you got this center line. But if you don't know the base diameter, you can draw like that method. Draw horizontal line first and then draw in this line, and this circle is tangent with that line. Okay. If you go the TPT, I draw this one line in here, something like this, and this one tangent with this base line. So this one is your new circle. Okay, this one your circle. Draw from here to this point. This one is your teeth gear profile. Okay. Okay, the next one is similarly, you know teeth thickness. This one is a module transverse plane multiply pitch divided 2. You got this value, right? This one is arc length. So you know the radius of pitch. This one pitch diameter divided 2. So radius of pitch this one. Arc length, of course, radius multiply theta radian. So you will get the angle, this one, 7.492. Okay, just draw this one. So go to the arc. Maybe you can use the line here and create the angle. How much? 7.492. Okay, this one is your point, your thickness of the teeth or tooth. Make it tangent line here, tangent C, and you can delete this. So you will have point, go to off this construction line, this draw here to here. Okay, So this one is your profile tooth of gear. So the rest of this just delete, quick trim. Oh, delete this outer diameter. Delete the root diameter. Okay, this one is your profile. Very beautiful, right? This one your teeth of gear. Okay, just exit. Okay, the next is this one is not center, right? I want to make it the center. This one is not center. So, okay, go back to PPT first. Wait a minute. Okay, we already draw this. Okay, you did a good job. Make a point intersection here. It's very detailed. And draw here point circle from here. From here to here, I mean. Okay, and then do quick trim and then exit workbench. We already did. Okay, now go to generative shape design. We want to rotate this profile. Rotate this profile about a tiny degree, about this 3.746 on the x-axis. Okay, go back to CATIA. Go to shape. Select generative shape design. Okay, this one, if you have selected, and there is the rotation. Where is the rotation? This one, I think this one rotation. Select this rotate. Select rotate. Okay, in PPT I show you the symbol. I think go back. The symbol. Select rotate. This one. Okay, and by right click select x-axis because we want to rotate in x-axis. Where is x-axis? This x-axis. Okay. Element is this sketch tool. Select this sketch element and the angle is minus. We want to rotate the clockwise. Okay, remove. So this one little bit center from this axis. Okay. Hide and show initial element. Select this one and then okay. So the profile is at the center right now. Okay. Still in generative shape design, we want to create the point. So here, in the center in here, I mean. So just type this with equal radius of the root diameter. This one is half of root diameter. Okay, this point in here, can you see this point? Okay, after After create this, still in generative shape design, select helix. Go back in PPT, this one rotate, okay, next. Create a point, okay, in the center of the profile, in here, okay. And then select helix. And in the generative shape design, there is a feature of call it helix. And in helix, we just have put the pitch value in here and height. Height is thickness of the gear, and starting angle 0, orientation counterclockwise, taper angle no need, axis is x-axis. You have to calculate how much the pitch in order to helix angle is properly 30 degrees. So in here I have a simple equation by triangle. If you have a cylinder like this, the helix angle can be represented by the triangular something like this, which is this one is length of pitch, and this one is of course circumference is the pi of diameter root, because this is root diameter. Okay, so the helix angle is simply by this equation you can find the pitch is calculated using helix angle of this, and this one diameter of root. Okay, pitch angle, put in this value. Very simple, right? Okay, now going to CATIA back. Go back to CATIA and select helix. Where is the helix? Could you find it? This one, helix, this one. Select this profile. If you have a spline here, just go this arrow, select helix. Starting point, this select point we already created. Axis, right click, select x-axis, and the direction is like this. Select reverse direction. Reverse direction. Pitch 40 millimeter, and the pitch is, we already calculated, this. You can see the profile of the helix with the height 40 millimeter and pitch 411.576 millimeter. Okay, this just finished. Okay, you don't believe this, and if you measure, select this with this plane, it will give the angle about 30 degree. So this will has the, it will give the helix angle 30 degree. Okay, because you give the page previously this value, we already calculated based on the triangle relationship. Okay, if you have this profile already, helix, and this profile, so go back to part design, select, go back part design. Okay, in the PPT, select rip in part design, select part design. I already create the helix profile, this one, select rip, and then select profile, rotate 1, center curve, helix 1. pulling direction, YZ plane, and then OK. You will have the teeth profile, something like this. Okay, go back to CATIA. Select grip. Profile this. Center curve this one. And this one is not, maybe you can see there's something like this. So you have to go the pulling direction, select this plan. Okay. So now become beautiful. And okay. You can hide this point. Okay. So the next you do is after get this profile, here helix profile. The next is do fillet 1 mm. Select this line and select this line. Okay. Okay, this one complete your helix gear suit profile. We are almost done. Almost done. Go back to PPT. Okay, we already did this one. Radius 1 mm. Select two edges. This edge, and this edge. And then press OK. Next. And do circular pattern, of course, with complete teeth number 24 for this gear. Reference element, in this case face, or you can select x-axis, is I think result is same. Where is the, maybe we have to move this. I'm so confused with this idea. Okay. Complete crown 24. Right click, x-axis. Wow, very beautiful. Right, this one is your helix angle. I mean helix gear, helical gear, I mean. Okay. It takes time a little bit. Wow. Okay, this one your helical gear. All right. With module 3 and helix angle, pressure angle 20 degree, and the helical angle about 30 degree. Okay, we are almost done. In here, go to the front view. Go back to PPT. We already did this. Done. This one is done, and create the sketch on the YZ plane with the keyhole similar like this. Radius 15 from here to here, 20 mm from here to here, 8. Select this plane, create sketch, select the keyhole, select this one, and select this one. And this, how much? This 15. 15. I think we delete this radius and draw line. Replace with line. Oh, this one is not symmetry. Destination not valid. We have to select in order to symmetry. Create the symmetry. And this one 20 millimeter. Surely 20 millimeter. Oops. 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 I just want to draw this. How much is it? 8. 8. Okay. Okay. We are done. Finally. Go to pocket. Up to next. Yeah, finish. Yeah, finish. This one. Oh, this one is wrong. This one not do pad. I do wrong. This one pocket. Delete this image. Okay, save it. I'm sorry for that. Okay, this one helical gear final. 30° and module 3. Finish. Good job. I hope everybody don't have any trouble with this, okay? And then save it. Pinion gear, and this one is helical gear. Okay. Thanks for attend this lecture. I hope if you have any question, just email me or contact me. And I think this gear is a basic component in many mechanical part, so I think it's important to know how to draw this in CATIA. Maybe it's very useful for you. You have to know this how to draw the gear because you are in mechanical engineering. Okay, so you have homework for this week. This one is homework, very easy homework for you. We have something bracket like this. I already have the clue in here using solid combine. Solid combine. First, you draw sketch like this, like this, 120, this one, and sketch 2 with a different plan, you know, with for example in here YZ plan and this one another plan. So by using solid combine, select sketch 1 and sketch 2 and normal to profile, and you can get the combination of solid, something like this. Okay, this one your homework. Erase. And using solid combine, you can draw this easily. This profile easily. I'm surely. Okay. And the second homework is same, using solid combine. The first, you draw like this profile and this profile for another plane. This profile and this profile should be perpendicular. So the first to draw like this profile and draw this profile, and then using solid combine you will have this profile. Excellent, right? I hope you don't have any difficulties to do homework, and there is no midterm exam. I think for this class we decide it's very difficult times due to coronavirus. So I think we decide no midterm exam. If online exam, I think everybody will cheat. So it's better homework, increase percentage for your homework. So I think just do homework faithfully. Okay, for this one, enough for today. Thank you very much. I hope you all safe and make a gear at your home. Okay, thank you for attend this 6 weeks 3D modeling class. I hope you keep healthy and safe. Stay safe at home. Okay, thank you very much. Thank you.